Now, chemical properties of metals. Have you ever wondered that what happens if we burn metals in the air? So, whenever metal is burnt in the air, definitely air consists of many other gases too, but we suppose whenever metal is burning in the presence of oxygen, it forms metal oxide. So, for example, when sodium is heated in the air, it combines with the oxygen to form sodium oxide. So, let us have a look at the reaction. Sodium plus oxygen producing sodium oxide. This is the formula of sodium oxide. So now some metals oxides like aluminium and zinc, they also show acidic behavior. So we studied in the previous slide that only and only non-metal or non-metallic oxides are basic or are acidic in nature, whereas metallic oxides are basic in nature. But some metal oxides like aluminium and zinc, they show acidic behavior as well. So that's why they are called amphoteric oxides, which means dual behavior. Aluminium and zinc oxide can react with both acids and bases to give salts and water. Let us have a look at the reactions. Here, aluminium oxide is reacting with acid and it is producing aluminium chloride along with water as its byproduct. And in the case of base, aluminium oxide is reacting with base to produce sodium aluminate and water as its byproduct. Here we are talking about the metal oxides. So most of them are insoluble in water. For example, let us take example of beryllium oxide. It is a very famous example of metal oxide which is insoluble in water. However, sodium and potassium oxides dissolve in water to give alkalis. Sodium and potassium individually even reacts vigorously with water. So, their oxides, when dissolved in water, produces alkalis. For example, here is the sodium oxide. When dissolved in water, it produces NaOH, sodium hydroxide. It is alkali in nature, that is, this is also soluble in water. We studied about this in our previous chapters. Whereas potassium oxide plus water, when dissolved in water, it produces potassium hydroxide, which is again soluble in water. Alkalis are basically the bases which are soluble in water. So now different reactivities of metals with oxygen. So potassium and sodium, they are highly reactive metals. So whenever they are exposed to air, they react so violently that they may catch the fire. So hence sodium and potassium must not be stored in air. They must be kept under kerosene. So here is an image showing how the potassium or sodium should be stored. It is stored under the kerosene. So here is a did you know fact. The process of forming a thick layer of aluminium oxide is called anodizing. So this is a very famous term, anodizing. So I'll explain about this later in the slides. So aluminium oxide makes it resistant to further corrosion. So it is useful if the layer of the oxide is thicker. So what we do here, suppose we have iron. So on iron we form a coating of aluminium oxide. So the aluminium oxide coat, it will make it resistant to the further corrosion. Now what is anodizing actually? So anodizing is a process of electrolytic passivation to increase the natural oxide layer's thickness. So it increases the natural oxide layer's thickness on the surface of metal parts. For example, here we have iron. So this converts the metal surface into a decorative, durable, corrosion resistant anodic oxide finish.